Due to the Figure 4 technology, one layer can be produced in only 3 to 4 seconds, meaning component production can be sped up quite significantly. Injection molding is a process of creating vast quantities of parts fast. The Figure 4 uses an additive process called digital light processing, and this uses UV light to cure resin in a vat, which is shone from a projecting display underneath to cure a whole cross-sectional layer of material at a time. And this gives super fast print speeds without compromising the quality. So how do these two processes compare? What similarities can we draw from them, and which manufacturing technique is best for your industry? Let's take a look. Let's first talk about quantity. If you're looking for high runs of large mass production, for many years the go-to method has been injection molding. This process can produce hundreds to thousands of components every single day, allowing for very rapid production. Traditional 3D printing methods used to be relatively slow, taking time to produce even one layer of material. But due to the Figure 4 technology, one layer can be produced in only 3 to 4 seconds, meaning component production can be sped up quite significantly. Additionally, it takes the same time regardless of part quantity in the build area, meaning that the more parts you can get on the bed, the faster per part the technology becomes. The Figure 4 also has the easy ability to be scaled up, allowing multiple printers to run on the same system with minimum downtime of production. One of the main downsides of injection molding is the initial startup costs. Tooling can be very expensive, and if you get it wrong, it can cost thousands to rectify. The injection molding machines are also quite large, very bulky, and often quite costly to operate, and can have hefty power consumption ratings. The Figure 4, however, is a ready-to-go machine that just plugs straight in without much installation needed at all. And each part is created from scratch using the resin in the vat, which means that there is zero tooling cost. And changing the design is all digital rather than having to waste material on new tooling every time. Now, not only is the Figure 4 able to be used for small mass or large batch production, it can also be used for prototyping. Whilst typical lead times for part prototypes can be weeks, the Figure 4 will produce components in next to no time, without needing to get additional machines as well, making it available to everyone. With injection molding, it can also take time to get the tooling made, whereas with the Figure 4, it's simply a few presses of the buttons and the software 3D Sprint does most of the setup for you within minutes. Furthermore, if multiple iterations of a component are needed, it can be quite labour and time intensive to swap over tooling parts in injection molding machines, but nothing is needed to be changed on the Figure 4. The element of design is probably the most significant factor with how the two processes differ. The ability to quickly change the design with a simple tinker on your CAD software provides limitless potential for these machines and ensures you're not limited to a design once you've started making it. This allows really easy iterations, customizable components, and ensures adaptability with your design. Moreover, any shape is achievable. With injection molding, you're typically limited to strict design guidelines such as maximum and minimum wall thicknesses, inability to produce overhanging parts, and risks of warping with flat, thin walls. You're also often left with scarring on components in the form of flashing, whereas with the Figure 4, 3D Systems' easy to break away support leaves little to no trace of where support structures have been. Finally, let's talk about material. Now, with typical injection molding processes, we have to use a thermopolymer to create our components, as the process requires melting the plastic down to form it into shape. This process has certain limitations, such as, for instance, there's now a risk of warping or further melting if exposed to heat in the future. The Figure 4, however, uses 3D Systems' own range of thermosetting polymers in the form of resin that have had long-term testing performed on them for decades. A wide range of materials are available, suitable for most applications in your industry. And these materials can be stored in separate trays as well, meaning that swapping between them is super easy and only takes seconds to do. So we've covered today the differences between more traditional manufacturing technologies and possibly a replacement for them as well. Now, as it stands, additive manufacturing technologies don't quite replicate the vast speed and production quantity of injection molding. However, the process is constantly improving, getting faster, getting better, getting more competitive. The quality is definitely there. The adaptability is a very exciting factor. And if you're looking for low mass production runs, high batch, or even one-off prototypes, then the Figure 4 is certainly something to consider.